Hi guys, quickly let's quickly start the today lecture and quickly press the like icon as well as subscribe this channel for getting instant update from my side. Okay, and as well as press the bell icon with two dots so that you get update. Okay, so I am going to start today our lecture, further continue the topic the last from the last time I left this up to this point. Today we have to start from this. Okay, so I am going to start from here. Let's start and understand the things. Density is, what does it mean? We place an edge between two core points Q and P if they are within distance epsilon. And along with we along with me try to read with try to read yourself but in your head, not in your mouth. We place an edge between two core points Q and P if they are within distance epsilon. Density is, we place an edge between two core points Q and P if they are within distance epsilon. Density is, we place an edge between two core points Q and P if they are within distance epsilon. Try to understand semantic meaning of this sentence. We place an edge between two core points Q and P if they are within distance epsilon. This is Q point, this is P point, and distance from this to this point within epsilon, and you can say equal to epsilon. Distance between this and this also equal to epsilon, and within epsilon. These place and is between two core points Q and P if they are within distance epsilon. Density connected. A point P is density. A point P is density connected to a point Q if there is a path of edges from P to Q. Density connected. A point P is density connected to a point Q if there is a path of edges from P to Q. A point P is density connected to a point Q if there is a path of edges from P to Q. Density connected. This point density connected. Density is and density connected. A point P is density connected to a point Q if there is a path of edges from P to Q. A point P is density connected to a point Q if there is a path of edges from P to Q. Are you getting meaning of this? Guys, try to read with me, but I try to explain, but you have to try in your own head, not like me. Are you getting? Density connected points means a point P is density connected to a point Q if there is a path of edges from P to Q. Density connected means if we place an edge between two code points P and Q if they are within distance epsilon. Density connected. Density is we place an edge between two code points Q and P if they are within distance epsilon. Density connected. A point P is density connected to a point Q if there is a path of edge from P to Q. Density is V. Density is they are using. So density is we place an edge between two code points Q and P if they are within distance epsilon. Now starts algorithmic steps. Algorithmic steps. We focus while I am delivering a valuable information regarding this topic. Definitely, it will definitely help you in interview. So please focus over here. The alg the algorithmic proceeds by arbitrarily picking up a point in the dataset until all points have been visited. The algorithm proceeds by arbitrarily picking up a point in the dataset until all points have been visited. Try to understand, guys. I, once again, I telling you this. Try to understand. First, you should take initiative to read. then you definitely find some doubts, some points, some which are you are not getting. Then I will in the lecture you definitely focus. You will be focused. You will be focused because you will be interested and eager to know the meaning of this. Otherwise, you will start learning from here. You will be focus less. You will focus less, and you will might get doubt later. We focus and continue with algorithmic proceeds by arbitrarily picking up a point in the data set until have been visited. First, they are telling algorithm proceed by arbitrarily picking up a point in the data set. The algorithmic proceed by arbitrarily arbitrarily picking up a point in the data set until all points have been visited. Means you have to randomly pick a point. That means you have to select randomly a point. You have to select randomly one point until all points have been visited. Until all points have been visited. Are you guys? Please on YouTube, please on YouTube, please on YouTube, visit my channel and like, subscribe, and share so that the person who are needy they will get benefit. The share of this will get in your account. So please share my YouTube channel, please. Okay. And the meaning of this randomly choose a point in the dataset and until all points have been visited. Okay. Next, if there are at least minimum points within a radius of epsilon to the point, then we consider all these points to be part of the same cluster. If there are at least minimum point within a radius of epsilon to the point, then we consider all these points to be part of the same cluster. If there are at least minimum points within a radius of epsilon to the point, then we consider all these points to be part of the same cluster. If there are at least minimum points within a radius of epsilon to the point, then we consider all points to be part of the same cluster. If there are at least minimum points within a radius of epsilon, the point, then we consider all these points to be part of the same cluster. Second point, they are telling if there are at least minimum points within a radius of epsilon. Up to this point, they are telling there should be a minimum points. The minimum points is the hyperparameter. This value of this hyperparameter, we select. We want 3 points. If we want 4 points, if we want 5 points, this is up to to end user. This value we we enter this value. So if there are at least minimum points within a radius of epsilon in the point, then we consider all these points to be part of the same cluster. So they are telling there if there are at least minimum points within the radius of epsilon to the point, then then we consider all points to be part of the same cluster. Okay. They are telling if there are at least minimum point must be within the radius of epsilon to the epsilon radius of epsilon to the point, then we consider all these points to be part of the same cluster. In simple terms, you can say in the radius of epsilon, the number of points found they are considered as a part of same cluster. But for to assign for point for a point and noise point, you must know number of minimum points must be there. Okay, this is the meaning. Third, the clusters are then expanded by recursively repeating the neighborhood calculation for each neighborhood point. The clusters are then expanded by recursively ac- repeating the neighborhood calculations for each neighboring point. The clusters are then expanded by recursively repeating the neighborhood calculation for each neighboring point. Meaning of this point. The clusters are then expanded by recursively repeating the neighborhood calculation for each neighboring point. The clusters are then expanded by recurs- recursively repeating the neighborhood calculation for each neighboring point. Mean they are telling you start from a single point or you keep continue to expand size of cluster by measuring the distance of all your neighboring points. If it fall under the epsilon, you consider this. It don't fall and means you continue to this. This is the meaning of this. Label points are core, border, and noise element node points. Label points are code border and noise eliminate noise points. Noise eliminate noise points. Label points are no core, border, and noise. And but we eliminate noise points. And for every code point P that has not been assigned to a cluster. For every code point P has not been assigned to a cluster. For every code point P that has not been assigned to a cluster. For every code point P that has not been assigned to a cluster. For every code point P means for every 4.3 that has not been assigned to a cluster. Okay, noise point. They are talking about the noise point for every 4.p that has not been assigned to a cluster. Create a new cluster with the point P and all the points that are density connected to P. Create a new cluster with the point P and all the points that have been density connected to P. Create a new cluster with the point P and all the points that are densely connected to P. Creates a new cluster with the point P and all the points that are densely connected to P. Create a new cluster with the point P and all the points that are densely connected to P. Assign border points to the cluster of the closest core point. Assign border point to the cluster of the closest core point. Assign border points to the cluster of the closest core point. Assign border point to the cluster of the closest core point. And parameter estimation. For DBSCAN, the parameter epsilon and minimum points are needed. Means there are two hyperparameter in this algorithm. We that means sorry that means we have to put and enter the value of these hyperparameter. This is the not system selected parameter. This is the humankind person who is using this algorithm means the end user put values as per their willing and keeping the mind the best outputs. That means minimum points. As a rule of thumb, the minimum points can be derived from the number of dimensions in the dataset. Minimum points always greater than equal to d plus 1. Minimum points 1 mean does not make any sense. Of minimum points less than 2, the results will be the same as of higher theoretical clustering with the single link metric with the dendrogram cut at height epsilon. Now, if they are telling if you select minimum points less than 2, in the case the result will be the same as of high radical clustering with the single link metric with the dendrogram cut at height epsilon. Metric minimum points is less than equal to 2. The result will be the same as of high theoretical clustering with the single link metric with the dendrogram cut at height epsilon. Minimum points must be chosen at least 3. Minimum points must be chosen at least 3. Minimum point must be chosen at least 3. Minimum points must be chosen at least 3. Minimum points must be chosen at least 3. Epsilon. The value for epsilon can be chosen by the using k distance graph plotting the distance to the k minimum points minus 1. Nearest never nearest ordered from the largest to the smallest value. Okay, अब now you might get in your mind you get idea how do we select distance epsilon. For this, they are telling the value for epsilon can be chosen by using a k distance graph, plotting the distance to the k nearest neighbor, ordered from the largest to the smallest value. This is the clue they have shared with us. The value epsilon can be chosen by using k-distance graph, plotting the distance to the k minimum points minus 1, nearest neighbor ordered from the largest to the smallest value. Epsilon. The value for epsilon can be chosen by using a k-distance graph, plotting the distance to the k means nearest neighbor ordered from the largest to the smallest value. Complexity, 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 complexity is 0 best case and worst case. Advantages of DBSCAN is great at repeating is great at the is great at separating clusters of high density versus clusters of low density within a given data set. Is great with handling outlier within the data set. Disadvantages of DBSCAN does not work well when dealing with clusters of different densities. While DBSCAN is great at separating high density clusters from low density clusters, DBSCAN struggles with clusters of similar density. While DBSCAN is great at separating high density clusters from low density clusters, DBSCAN struggles with clusters of similar density. Does not work well when dealing with clusters of different densities. While DBSCAN is great at separating high density clusters from low density clusters, DBSCAN struggle with cluster of similar density, struggle with high dimensionality data. Thank you guys, and from tomorrow I um, have planned to start tree-based algorithm. Okay, so I am going to conclude and wind up the lecture there. If you have any doubt and queries, so with this you have to mention in your comment box. Thank you for patience.